Welcome to the latest episode of IoT Leaders Podcast, the podcast that attempts to demystify the very complex and often confusing world of IoT. And I'm absolutely delighted in this episode to welcome Steffen Sorrell. Steffen is the Chief of Research at Kaleido Intelligence. So Steffen, welcome to the podcast.
Yeah, hello. Thanks for having me on, Nick.
Sure, you're welcome. And this week's episode is all about the eSIM. Mm-hmm. And we're going to really try and double click on this and demystify the eSIM, not just in terms of a technology, but in terms of what it is, why it's needed, what problems it solves, what are the current advantages and disadvantages of it, the state of the market, where it might go in the future, but ultimately, what are the benefits to customers in terms of deploying IoT projects of the eSIM? Now, I have to say to our listeners that Kaleido Research and Steffen in particular have released a 20-page research report on this that SI was involved in, and that is available now. So if you're finding this absolutely fascinating, which I hope you are, don't feel the need to make furious notes on this, because pretty much all that we cover, hopefully, is in the report and a lot more. But I'm sure, as always, we'll get lots of opinions and views on the wider subjects as well. So the report, just so you know, will be available through SI's website, and it's called the Global IoT Connectivity Through Localization White Paper. You'll find that, and they'll give you a lot more detailed information on this. So with that, let's get going. And as we always do on these podcasts, Steffen, let's first of all get to know you. Mm-hmm. As a person. So I don't know, where were you born? How did you end up in a market research and analyst company?
I was born in Eastbourne, which is in the south of the UK. I've always thought of myself as a Brighton lad, though. I went to college there, and after university, I went to live back there for a bit. And found it a bit more exciting than.
And what did you do at university, just as background?
Actually, I did a modern languages degree, which is a bit of a ways away from the industry I'm in now. But after I finished my degree, I started working in the FMCG sector. I became an analyst.
That's fast-moving
in fast-moving consumer goods, right? So I was working for a big American company there as an analyst, and while I was doing that, I sort of got a bit more interested in things like software development. So I started doing another degree remotely while I was doing this, and I came across the Internet of Things during this software development course, and that led me to a research house called Juniper Research.
Okay, so let's just take it easy. You covered a few things there. You did a degree in modern languages.
Yep.
Then you were working in the software field, and you started doing another degree. Is that what you said?
I was working in the FMCG sector.
FMCG, excuse me.
And then
doing another degree.
I was doing a degree in my spare time.
Yep. And that led you into IoT.
That got me interested in IoT. I first discovered about the smart home back in those days. That led me to become interested in becoming a research analyst. So. And
that took you to Juniper.
Yep. So I worked at Juniper Research for 10 years or so. And funnily enough, I was covering the IoT side of the business. So actually my first report back in the day was on the smart home sector. Okay. I worked there over the years, and as time passed, I think myself and a couple of colleagues who were also working at Juniper felt that maybe there were some areas of markets that we were looking at that we could cover in more detail, go a bit deeper, really get under the skin.
Right. Juniper's a pretty broad research.
That's right. Yeah, that's right. Yeah. They do cover a lot of areas.
Yeah.
But I think we wanted to do a a bit more. So we then branched off a couple of years ago. And myself and two colleagues from Juniper, we started a research firm called Kaleido Intelligence. So I'm one of the founding members. And in that, we are looking at mobile roaming as well as mobile connectivity.
Perfect background to the podcast. And so with that background, that's why I said I couldn't think of anyone better to cover this subject, which is a complicated one. So let's see if we can unpack it. And, let's start off by, first of all, talking about a subject that we have raised on this podcast a few times before, which is, I call it what the hell happened? Because if we go back in the day, and I first started off looking at this area about 2010 or so, when I was in Cisco, and we at Cisco and others like Ericsson and IBM and others, we all confidently predicted 50 billion things are going to be connected. Smart home, as you say, was clearly going to be one of them, but not just smart home. It was basically anything with power and an IP address would be connected by now. We'd be here by now.
Yep.
And then now we're in 2021. We look back and say, well, actually we got to 11 billion things. So we got to just over 20%. And I call that one of the biggest misses in the IT industry. So from your point of view, because ultimately this is a road that's going to lead to how the eSIM and the way it's implemented can address some of these issues. But from your point of view, let's start off with, what do you think are the main issues to do with why we as an industry missed so badly?
I think the biggest issue is that it's not as simple as everyone thought it would be. You can't just say, oh, well, look, here's my device. I can ship it anywhere in the world. It will work. It will provide me data, and I'll be able to get insights from that data. It's nowhere near that simple. I mean, you've got complexity around the hardware design for IoT projects. IoT is a mishmash of different ideas, different end goals, different ways to do it, which means the majority of products, it's not just like an off-the-shelf thing. Like it's not like a mobile phone where you just buy it off the shelf and it works.
And I think that is a really key thing, because we find that, we've said before, we have 2,000 IoT, we only do IoT as well, and we have 2,000 customers. And it is amazingly common how often customers come to us who are in the IoT business. I'm the project manager for an IoT project, but there is this perception that, well, I can put a SIM into my mobile phone and it works. So I kind of assumed that was a given, and I'm going to concentrate on all the other elements of IoT, particularly the application integration, the data usage, the security. But something as basic as the device and the connectivity, it's difficult. I mean, it's really difficult, isn't it?
Yeah, that's right. I mean, when you look at the connectivity market today, I mean, when you have an IoT device, you can't just have one SIM and say this thing is going to work anywhere in the world to the quality that I need it to work, because of the way that the industry is structured. It's not that simple.
And the industry is structured, and if you look at the MNOs, the mobile network operators, the industry is structured in a whole series of vertical proprietary stovepipes. I mean, essentially, the MNOs have a proprietary SIM, and that proprietary SIM forces the connection onto them. It's the way the model works, which works for cell phones with some roaming, and we'll get into this, but clearly does not work if the goal for IoT, if the goal is, the holy grail is what you said, which is, why couldn't I just have one SIM in a device that just connects? Yep. And I think for all of us as an industry, we either ignored the problem or we kind of assumed that would be possible back in 2010, and now we're faced with this issue. So we know that connectivity is an issue. So let me go to the next question, which you must get asked all the time, because after we say to people, well, it's not that simple, And they go, well, what do you mean? And their eyes start to glaze. Particularly oh God, I didn't realize we had to do this. And I don't know anything about hardware. And they say, well, can't I buy a device off the shelf? Yeah, but it's not going to be optimized for the use case, you want to solve. So it's not like the iPhone. So then the question then becomes, but surely roaming solves this, because it seems to solve it on my mobile phone. Roaming, isn't that what roaming, never mind this eSIM stuff. I mean, the first thing they say is, yeah, but isn't that what roaming does? Now, you guys are real deep experts on roaming. That's what your website says that you do. So what's your take on that? So, why doesn't roaming just solve that problem?
I think first thing we have to do is go back to how roaming was originally established. So it's a series of agreements between operators based on an understanding mostly of bilateral traffic. And these agreements were made at a time when the Internet of Things, or the business model was made at a time when the Internet of Things didn't really exist. M2M was barely even a thing at the time. And really the idea is that, we humans like to think we're special, but actually we're quite predictable in terms of how we travel, how we use our devices. And that is what the roaming business model is about. It's about predictability in terms of, okay, this number of connections or this much data is going to be used in a roaming scenario on my network for a short amount of time. People don't go abroad and live there and then roam.
Normally it's like 3 months, isn't it?
Exactly.
3 months on the network, and then by which time you've gone back home. Whatever.
Yeah, like longer than 90 days, you could consider that device as permanently roaming, which is a special use case and is actually challenging, which I think we'll probably get into a bit later. But when you have that business model transferred to machines, and we talked just now about how IoT is very customized, the fact that it's bespoke from project to project, the type of use case is different from project to project, which means the data, the usage, where these devices are shipped and used is no longer predictable. And that doesn't fit the roaming business model, which is based on that predictability. So that's one side of it in terms
of just to make sure I understand that. So that is an interesting way of looking at it. If I repeat it back, what you're saying is the roaming agreements were basically built out of the consumer voice, essentially.
Yeah, exactly.
Where there was a degree of predictability. So I'm network A, and I'm going to say I'm a European MNO, and I'm going to do a roaming agreement with a US MNO. But it's because I know that I've got customers on my network in the UK, and when they go on holiday to the US or they work perhaps for a few weeks there, I know that they're in the US. They typically are only in the US, and then they're going to come back within 90 days. So I'll just do an agreement, like a reciprocal trade agreement, if you like, between the MNO in the US. The MNO will probably do a similar one for American tourists, coming to the UK, and we'll just say we have a quota. I'll let you have I guess are they structured, these roaming agreements, are they structured around a certain number of devices and or a certain percentage of the traffic? Is that typically how they get structured?
Yeah, pretty much. So it's based on expected volumes. But I mean, the major difference is, today's smartphones are all high volume data devices. So when wholesale agreements are made, and those are based on traffic, then an operator can expect a reasonable return. But then when you have an IoT device, a lot of those devices are not consuming
not a lot of data.
Exactly.
Yeah.
So for example, when we look at the roaming market, when we look at the wholesale, so the inbound roaming market in terms of revenues, over 70% of that market is covered by IoT devices that are using more than 100 megabytes per month, which is a very unusual amount of data for an IoT device to be using. Normally it's definitely less than 100. In some cases, maybe between 10 megabytes or something. And the revenues that you can get from that are very, very small from a wholesale perspective. So in that sense, the business model to allow lots of devices to come in that don't produce a lot of data is not a great one. You're not getting any money from the data consumption, but you're still having to cover your signaling overheads. So the IoT devices are still sending traffic over the signaling.
Pay for physical infrastructure, Cisco routers and switches, say, or pipes.
Yeah.
But you're getting a percentage of a small number. And as data prices drop and IoT devices start proliferating and start sending, frankly, less and less data, narrowband and LP1, you're getting a percentage of a declining number, but your Cisco routers and switches aren't coming down in cost accordingly. So that presents would you call it like a growing financial disincentive
exactly.
in the industry?
Exactly, yeah. I think we're seeing that fear of. So we talked about how a lot of IoT devices can spend a long time in the country in contrast to humans.
Yes, and you don't know in advance that it's not like I bought an airline ticket and I'm coming back in 2 weeks after my holiday in Florida. Yeah. I'm making 100,000 widgets, and a certain number of them, I don't know how many will be sold in the US and will stay there.
Yeah, and the more devices you have out there, the lower the incentive for the operator if they're producing small amounts of data only.
So the theme, Steffen, and we definitely hear this. I don't think people do. I'm glad we're shining a light on this, because I don't think people do understand this. Is that you're describing as an analyst firm that spends all their time doing this. In fact, you even left an analyst firm and formed another one just specifically to go into this. It's a model which is if I were to repeat, built for the consumer, initially consumer voice, but certainly the consumer market. Mm-hmm. B is based on a set of assumptions that are not just not applicable to IoT, but increasingly unapplicable to IoT. The number of devices, as the number of devices grows, the financial incentive and the practicality of roaming agreements drops.
Yeah.
And would you say that, and that's only going to carry on, nothing that you've said says that there's something coming, and certainly we'll get onto eSIM, but unless you change the model, what's going to happen is roaming is just not going to be financially worth it. Mm-hmm. And would you say for the operators, and if roaming goes away, then connectivity goes away. So would you say that this is one of the reasons why we're seeing, and certainly we're seeing this, an increasing number of roaming agreements being terminated at very short notice?
Yes. So there's two elements which are two major elements which are placing pressure on the roaming market apart from the business model. And this comes on the one hand from increasing operator hostility towards permanent roaming.
Yep.
And that's driven, of course, by the business model as well as emergence of things like Roam Like at Home in EU, which takes away some of the upside on the consumer side for wholesale. And the second side of pressure is on the part of regulators themselves, particularly in markets like China, India, Brazil, Turkey. Even the UAE now has a specific regulation which says that business data must reside within the country, which means you can't apply a traditional roaming model. Yeah. So the regulators are having a big impact on the one hand, while operators are having a big impact on the other hand. So if you're in the shoes of a customer, saying, okay, I want my device fleet out there. I know I want it to be out there for 10 years or more. Yeah. that pressure from the MN.
Surety of connectivity. I don't want to have to be someone who spends all the time monitoring roaming agreements and seeing whether they're there or not. And
exactly. I don't want to spend 60 plus months developing and testing and prototyping and deploying, only to find that a year later, either the regulator has decided that permanent roaming is not available,
and that can happen. So roaming agreements are not financially less and less attractive.
Mm-hmm.
So people don't want them. They get terminated regularly, and it appears to be increasing. Not surprising, given that the financial incentive is getting worse, and regulators are increasingly stepping up for a variety of reasons, frankly political, and as well as protecting the hometown hero in the country, and saying, like Turkey is a very good one, 3 months and you're off, unless you put a Turkcell SIM in it. So at this point, I guess we've shone a lot of light on just one element of why we didn't get to that magic $50 billion figure. I mean, this is not a nice, easy, predictable world for people who are wanting to roll out IoT deployments. So not surprising that some of the bigger projects, when you look at that 11 billion versus the 50, our research shows us that most of the 11 billion were small regional projects that didn't need to go single SKU globally around the world. And again, you're reinforcing why that is, because if you want to create one widget, manufacture millions, ship it around the world, and it just works, all the things that you talked about make it almost impossible. So let's pivot then, before everybody gets so depressed and think, I give up. I'm not going to do IoT. I give up, because the IoT has a wonderful opportunity to reduce costs and increase productivity, collapse supply chains. We've talked a lot about in this series. So on the horizon comes eSIM. And now the next thing people say is, don't worry, I know the roaming model is broken. And I know I know my model relies on roaming, but don't worry, eSIM, and then that takes us into EUICCC. eSIM and EUICCC, they're going to solve this problem. That's the latest thing, is don't worry about it. We've got it covered. So first of all, for people who don't know, maybe just a little bit, can you just briefly describe what the eSIM is when we talk about what is an eSIM and the EUICCC standard? What's that all about?
So eSIM is a little bit of a misnomer. It stands for embedded SIM, but actually doesn't have to be embedded. It can come in any SIM form factor. And really, the main goal of the eSIM, so there's two parts. You have the hardware side, which is the eSIM chip itself, and then you have EUICCC, which is a software framework for remote management and remote provisioning of the SIM card. So that's what separates it from a traditional SIM card, like you mentioned earlier.
Provisioning, the ability to push an IMSI, an international mobile subscriber identity, over the air into the SIM, as opposed to it being hard coded in as it is with a proprietary MNO.
Exactly. So you spoke earlier about how your traditional SIM, you're locked into the operator. With eSIM, that's no longer the case, because you have this mechanism via the software platform to download a new operator profile wherever you are in the world. So what that means is on the production line, you don't have to have different color-coded SIM cards depending on where they're going anymore. You don't even necessarily have to know exactly where they will end up anymore, because the eSIM contains something called a bootstrap profile, which is designed to provide a sort of a startup connectivity.
Always connect, wherever it is.
Wherever it is in the world, and then it will use that bootstrap profile to download or activate an operator profile within that country.
But that's the right one for that device.
Exactly.
So now I feel better. I'm a user. Now I feel better. We've solved all of our problems, have we? Not quite.
It's a little more complicated than that.
And EUICCC plays a role. We should make sure we cover that off as well. So I get the eSIM now. I'm seeing the light here. Say, okay, well, I have a eSIM. It's got a bootstrap. It connects, but it's connecting on the wrong network. But as soon as I'm connected, I can OTA over the air, push something in. That sounds good. So what's this EUICCC all about?
So EUICCC is a standardized framework made by the GSMA. So they have a security accreditation scheme.
Yep.
So they make sure that the production of a SIM card is secure with certified players. And on the software side, you have certified players as well. So you have two components for IoT called the SMDP and the SMSR, which is Subscription Management Data Preparation, Subscription Management Secure Routing. So,
and these acronyms are going to become very important in about, spoiler alert,
right? Yeah,
very important in about 5 minutes.
Yeah.
So pay attention.
So yeah, the SMDP is there to securely store operator profiles.
Right.
And then the SMSR is used to take that profile and download it onto the device in a secure manner.
Okay, so let's lay out the table in front of us. It's sounding good. It's sounding like we've solved everything so far. Of course, we know we haven't. But just for the moment, from the mess we had previously, called the current state of the industry, we now have three things. We have the eSIM, which is essentially programmable. It's over-the-air programmable. It has a bootstrap, so it will connect. So you can put one SIM in every device now.
Yep.
And then localize it or push an IMSI into it from an operator that you want locally. And then you have two critical bits of functionality, the SMDP, which is the database, if you like, of the profiles, the IMSI codes, the profiles that are available to be pushed in over the air. And the SMSR is like the switch. The SMSR is the switch that says, if this device is conforming or is placed in this location, then push this IMSI in from the SMDP list into the device. Mm-hmm. So sounds like we've sorted it. Now, you and I both know we haven't, but a lot of the reason I'm sort of dumbing it down, if you like, a lot of people, again, they come to us being a global company and say, oh, no, I've been told by other players in the market or whatever, the eSIM and the SMDP and SMSR will solve all these problems. And still 80% of IoT projects are failing, right? So we know there's another gotcha. So let's go to the next chapter, if you like. Why does what you just described not solve all the problems you talked about previously?
Well, there's a very good reason why when we look at eSIM today, there's a lot of devices actually enabled with eSIM, but only give or take 20% of those devices globally are actually using eSIM connectivity. And the reason is because of the complexities surrounding the SMDP and the SMSR. So
what does that mean?
It's not as simple as, if I'm a customer, it's not as simple as me flicking a switch and saying, okay, I want to switch from operator A to operator B, because the SMDP and SMSR live inside the operator's domain. And normally what happens is when you switch between one operator and another one, you also have to switch over to a new SMSR, a new SMDP, which requires some pretty heavy integration in terms of APIs. You've got billing schedules might be different between operators.
Like starting again.
Exactly. So this process can often take months. And
so it's not a switch. It's not a switch as people think, oh, I can switch OTA. So I'm on operator A. I need to go to B. Wait a second. I'm over. Or even if you've got your mobile phone, I have a Vodafone SIM in my mobile phone. If I want to move to EE, I can get a pack code and I can do it. But but you're saying it's a little bit more similar to that, because if I switch from Vodafone to EE, I've now got a contract. I had a contract with Vodafone. I've now got a contract with EE.
Yep.
I've now got a new pricing schedule. And in the case of IoT devices, if I've API integrated my device and the data into my backend application processes, I may have different set of APIs. I've got a different support number to call if things go wrong. So I'm enabling a transfer, but I'm enabling I'm solving the problem. And this is my words, and keep me honest. We appear to, with that level of implementation, we appear to be solving the problem for the MNO, and that MNO A can completely move the device to MNO B, and MNO A is done. But from the customer point of view, the customer now has got to do a reintegration for MNO B, which if you only had one or two devices, okay. Mm-hmm. But if you've got 1,000 devices, 10,000 devices, 100,000 devices, and you want to move them all the time to optimize connectivity, suddenly you've created even more work for yourself as the user.
Yeah, you're looking at months of work and a lot of money.
Months of work.
And this is one of the reasons why, when historically with eSIM, it's mainly been limited to automotive applications, because they were able to afford those kinds of costs, or at least absorb the costs, whereas other IoT segments couldn't afford it, and
exactly. They couldn't rewrite their systems, and
yep.
So we almost got there. It looked like we could have global connectivity, but actually, when we double clicked on it, there was yes, but at the back end. Okay.
Yeah.
Now, this wouldn't be an SI podcast unless we said, but there is another way. So I know you guys. In fact, that's how we started our business relationship, and indeed the trigger for the white paper is that we were briefing you about what we do and how specifically we solve that problem. Okay, so just for our listeners, we do SI does everything that Stefan has just talked about, except the key difference is two key differences. Is that we run our own SMDP and SMSR in our cloud platform, and we interconnect with a whole series of MNOs, so that the net effect is we can switch between MNOs on a global basis. So if you need localization in Turkey, we can switch you to a Turkish SIM. If you need localization in the US, we can switch you to Verizon SIM, the IMSI OTA into our SIM. Same for China, et cetera, et cetera. We've got 14 of them, but because we've got the abstracted SMSR and SMDP, although we're doing the switch from the user point of view, there is none of these issues that you refer to exist, because you're always connected to SI's platform. You don't have to change your APIs. You still have the same pricing. We handle, as we get fixed pricing. You have the same support number. So our belief is that the only way you can implement the eSIM, deliver on the eSIM promise, is to abstract the SMSR and the SMDP up into a high level, which we call like a virtual mobile network operator, VMNO, as opposed to an MVNO, a mobile virtual network operator, because mobile virtual network operators typically come from the consumer background and enable the transfer from A to B, but the user then has to do all that work, that months of work that you're referring to. So we've actually created a lot of the functionality that is within the MNO as a software layer in the cloud, which means the devices can switch and all of these interfaces don't have to change. And that was the genesis of the research report. Your view as an independent analyst on that solution, and whether or not that is a step forward. I'm not saying it's the whole answer, but a step forward in solving these issues.
Yeah, well, I mean, like you said, when your provider, so you're a provider who has many different agreements with operators around the world. So in terms of that, you're able to connect with, over 700 network operators.
Over 700 different networks with localization and roaming agreements, 14 localizations and however many different roaming agreements. So basically ubiquitous.
Yeah, exactly. So from a coverage perspective, that's pretty much sorted. But the key differentiator here is, like you mentioned, the ownership of the SMDP and SMSR. I mean, if you can avoid that integration cost, if you can avoid the headaches that are associated with switching APIs or new management in terms of your business relationship, then the business case for eSIM becomes a lot more attractive. Right. But the fact is that eSIM itself is a little bit more expensive than a traditional SIM, because in most cases there's more memory on the cards, it's a newer technology, and of course then you have those software components.
It's like an application. It's almost like a small computer. There's an application on the card and software components that enable these capabilities. Yeah.
So I mean, I think companies will be able to see, okay, I can see why I'm paying a little more for eSIM from sort of a high level perspective, but they might not understand the full challenge that has gone into it in terms of investment and complexity, which has perhaps made them shy away. But if you're able to deliver a solution that removes a lot of that complexity, then I think the idea of paying a little bit more to receive something that's future-proof and standardized by the GSMA gives you a guarantee for IoT projects. We talked about how roaming is perhaps not the best idea for long-term projects.
Yeah.
So eSIM is the answer to that. But if eSIM is too expensive, that might stop you from getting into IoT.
And that's why I said, Stefan, that I still don't think it's yet the Holy Grail, because in reality, it's an interesting scenario. You don't know in IoT, back to where we started, you don't know you're going to have a problem until you've had a problem. And then the second time round, you say, well, I'm not going to do that again. I'm going to make sure I fix that before I get started. So of our 2,000 customers or so, I would say 70, 80% of them have come to us after a failed project. And so, the SIM costs a little bit more. The service may cost a little bit more. But if that means you get 99% first-time global ubiquitous connectivity out of every device in every country, as opposed to 92 or 93% and have to swap SIMs, or you have to change your APIs at the back end because of the eSIM switching problems that we referred to, then you pretty soon realize that the costs of having to do all that work, or the costs of not having access to 8% of your devices, is many, many, many times greater than the cost of spending another 50 or 75 cents on the SIM. The problem is that until you really realize that they are going to be issues, that little extra cost for per SIM per device, it says, oh, well, you're more expensive than others. So that's why I think that we have to look at TCO, total cost of ownership, and ROI metrics, which is what the IT industry in general had to do, because it's about delivering a business outcome, and the business outcome is directly proportional to the percentage of connectivity, because what you're really after is the data, and getting data from 92% of your devices, 92% of coffee machines, 92% of lockers, 92% of heart monitors is not as good a business case as getting as near to 100% as is physically, technically possible. So we've made strides, and we are definitely seeing that this is the new model, the abstracted SMR, extracted SMDP and EUICCC enabled switching into a step 2 profile into an eSIM to get one product SKU. So we're definitely getting closer. At the risk of complicating a little bit more, and we won't have time to go into this as in as much detail. What about the guy who says, okay, I get all that, but the company I'm talking to tells me, oh, well, don't worry about any of that because there's something else coming. So, oh, no, wait. This is why it's confusing for people. No. There's something else. There's always something else coming. Now, this time, over the horizon comes the eSIM. Mm-hmm. So can we cover that on this as we're, you're educating people, I'm sure, so how is the eSIM fundamentally different, or isn't it, to what we just talked about?
It is, and it isn't.
Okay, that's an easy answer.
So eSIM basically takes the eSIM concept, but instead of a separate SIM chip, it's integrated into the system on chip itself.
It's firmware, it's software inside silicon, essentially.
Exactly. Yes. So what that means is that you have a smaller footprint when you're manufacturing devices. You don't need to have space for a SIM chip anymore, which means that you don't need to pay that extra cost for the SIM. So it saves you money, and also it means that your devices can be smaller, or you might actually have room to put whatever else you might want.
But does it presumably it also means that if you're going to go now, if the SIM is going to physically disappear, and it's not going to be on the board, it's going to be firmware inside the chip, the module, the modem, then presumably all the more reason why you need to not have lock-in, you need to have ubiquitous connectivity capabilities, because if you don't have it, the remediation process is not just change the SIM, you'd have to change the whole module if you didn't have it. Now the modules are a lot more expensive and difficult to change devices than SIMs are.
Yeah, I mean, it's funny you mentioned that. I'm sure there are some listeners who have caught onto or listened to eSIM and said, well, hang on, eSIM's not coming. It's already been commercialized. Well, actually, eSIM might well have been commercialized by a few vendors, but it hasn't been standardized in the same way that the EUICCC specification has. Yes. So right now, you can't take an eSIM and use that standardized framework to switch operator profiles at will. What's happening right now is that the GSMA is working on standardization, and then over the next 2-3 years or so, we'll start to see commercialization of standardized eSIM available on the market. And that will offer a lower cost hardware solution versus eSIM.
Okay, well, we've covered, Steffen, first of all, thank you for simplifying what is a very complicated environment, and we've covered a lot of ground. Mm-hmm. We've covered the connectivity, the complexity, the lack of adoption, the roaming, the commercial problems with roaming, the user issues, the declining price, the fractured, broken economic model of roaming, which leads to lack of surety going forward, the promise of eSIM and EUICCC, the reality of eSIM, the importance of the SMDP, the SMSR, and then the idea of an abstracted agnostic platform to solve those issues, and then into but we've still got some more issues to come, as there always is in the IT world. Some more issues to come with doing it all again in regard to the eSIM world. And so hopefully in the future we have another podcast where we say, and now this is how we can solve the problem in the eSIM world. But we don't need to do that yet, because there's only a certain amount of new technology that people can absorb. I think the key takeaway is that eSIM is needed, ubiquitous connectivity is needed, eSIM is an important part of the solution, and the SMSR and the SMDP and where they are resident are really important factors to take into consideration for listeners when considering particularly global IoT deployment projects. So a lot of content in this podcast. I want to thank you again Steffen. Also, give a shout out to Kaleido, your website. So you're a specialist in this area. This is what you do. And there is this 20-page report, which goes into what we've talked about and more in a lot more detail, which is available. In the meantime, let me wrap this up and thank our listeners. If any of you listening think there's a subject we should go into in more detail, this was one of those subjects that people said, can we really go into this because it's complicated and there's lots of claims and counterclaims. So hopefully we've clarified things for you. And if there's any other subjects you particularly want to go to us, please reach out to us, either to myself on LinkedIn, Nick Earle, E-A-R-L-E, of SI, E-S-E, Y-E, or just reach out to us on social media in other ways, and we will take your inputs into account for future episodes. But in the meantime, I'd like to thank this week's guest on the IoT Leaders podcast, Steffen Sorrell, who's Chief of Research at Kaleido Intelligence. Thank you, Steffen, and thank you for, as I say, taking a really complicated subject and simplifying it as much as is possible for our listeners. Thank you very much. And thank you to everyone else for listening. Thanks, Steffen.
Thanks, Nick.
Take care. Bye-bye.